Alright, so I figured out how to add my face to the bottom corner. I don't know if that's better or worse, but for this one we're going to look at the first assignment question. So if you follow along, again, your numbers might be different from mine, but you can solve them in kind of the same way. So try it first on your own. If you can't get it, then this is here to help. So for this first one, number one, a 3 ohm, 13 ohm, and an 18 ohm resistor are connected in series with a 24 volt battery. So I'm going to draw this out because, I don't know, I find it helpful to do. We've got a series circuit, so it's a single loop with 1, 2, 3 resistors in it. We've got a battery. And then to kind of label everything, we've got it's a 24 volt battery, 3 ohm resistor, a 13 ohm resistor, and an 18 ohm resistor. And as soon as we see that it's a circuit analysis with multiple different resistors, we're going to set up a VIRP chart, because that's what we do. So VIRP, and then we've got 1, 2, 3 different resistors. So I'm going to go R1, R2, R3, and then remember I've got that total row along the bottom. Setting up all my grid lines. Here we are. And now let's fill in kind of the things that we know here. We know that we've got a 3 ohm resistor, so that's one of the resistances. We've got a 13 ohm resistor, so that's another one of the resistances, and we've got an 18 ohm. And then it's a 24 volt battery, and again, anytime you see battery, again, that's our total thing. So that's going to be our battery here. 24 volt. Let's figure out what we're looking for. We're looking for the, can I write here? No. We're looking for the, oh, here it is, equivalent resistance. So that would be, I think, this box right here. Now this is a series circuit, so I'm always going to stress that you kind of go back, check your reference tables for your series circuit rules. I'm going to pull them up real quick. Oh cool, there they are. So here we've got, for our series circuit rules, it's these guys right here. And it looks like for that total resistance, I think we can just kind of add these all up, because it says like R1 plus R2 plus R3. So that's what I'm going to do over here. I'm going to take our first resistor, I'll add it to the second one, and I'll add it to the third one. 3 plus 13 plus 18 is 34. Cool, so that should be our answer to that first part, to number 1. Alright, now that we got number 1 down again, so that number 1 is going to be, that's the 34 ohms. For number 2, what is the current in the circuit? So if I want the circuit as a whole, it sounds like what we're going to do is we're going to look for this total value, right? The total current moving through the circuit. And for the circuit as a whole, it looks like we know the resistance. It looks like we know the voltage. So I think we can find the current just using Ohm's law, right? We got V, we got R. Let's solve for I. So I'm going to do R equals V over I. For R, again, we're going to stay in that same row. That's this one right here. So we've got 34 ohms is equal to 24 volts over I. And then solving gives you, I got 0.706. 706, and then amps the unit. So I'm going to throw that in over here. 0.706 amps. Number 3. What is the current in each? So again, that's our answer over here. We found the total current in the circuit is 0.706 amps. Now we want the total current in each resistor. So anytime we're kind of moving up and down these columns of the VIRP chart, let's consult our reference tables again. So when we pull that up, we've got, oh, it looks like for a series circuit, all those currents are the same through every device. Because I equals I equals I equals I. So it's all there for you, which means that the current through this one is 0.706, and this one is 0.706. .706, and this one was .706, and so to answer our question over here, I think we can just go with an answer of .706 amps. Because again, in a series circuit, sort of a unique thing for series circuits is that the current is the same in all of the different devices. Okay, next up, number 4. A 6-volt storage a 6-volt storage battery is connected to 3 resistors of 6.75, 15, and 23 ohms respectively. The resistors are joined in series, so we know this is a series circuit. Calculate the equivalent resistance. Okay, so again, we've got multiple devices. I'm going to draw it out just like I do every time. We've got 3 devices in series. Sounds like they're connected to a battery. And, you know, again, every time we've got these multiple devices, we have a strategy for that. It's a VIRP chart. VIRP, R1, R2. I think we've got 3 resistors, and then our total row. And then again, we'll fill in just kind of whatever we can, and then we'll just take it from there. So I think we've got a reading mine. I think I've got a 6-volt battery, so that's going to be 6 volts in the total. A 6.75 ohm resistor, so this is 6.75 ohm resistor, a 15 ohm resistor, and a 23 ohm resistor. Alright, we want that equivalent resistance, which is this guy down here, the total resistance. And I think that, I'm going to pull it up again, even though it looks really similar to the problem we just did. I think to find the equivalent or total resistance, we can just add these all up, right? It's the first one plus the second one plus the third one and so on. So that's what we'll do. And so when we add them all up, I've got 6.75 plus 15 plus, plus 23 equals, I think you get 44.75 ohms, and that I think is our answer here. So that's the total equivalent resistance, 44.75 ohms. Alright, number 5, what is the current in the circuit? Again, let's just figure out what we're looking for here. We're solving for the current, so that's I, and it's the total for the circuit that I'm interested in. So, we know V, we know R, we're solving for I. I think, right, we've seen that before. That sounds like Ohm's law. R equals V over I. Staying in this row, R is 44.75, so 44.75 is equal to V, it looks like is 6, getting that from this box right here. And then we're solving for I. So quick math, I got a current of 0.134, so I equals 0.134, and I think the unit is amps, so 0.134, sorry, I'm completely out of room there, amps. Alright, and that's our answer, 0.134 amps. And that's number 5. Last up, number 6. Alright, number 6, probably the one I would expect students to have the most trouble with, because there's going to be a couple steps to this, and it's a nice example of why you have to use the VIRP chart when you answer these questions. So if you got resistances of 2.3, 3.9, and 6.2, and a 20.1 volt battery all in series. So we've got a series circuit, and again, I like drawing these out. So that's 1, 2, 3. We've got a battery. Cool. Let's give these all labels here. We've got 20.1 volts for the battery. We've got 2.3 ohms for the first resistor, 3.9 ohms for the second one, and then 6.2 ohms for the last one. And we want the potential difference, which remember, Potential difference is just another word for voltage across the 2.3 ohm resistor. So again, it's multiple devices. We're doing a verb chart. V, I, R, P, R1, R2, R3, and then the total. I did not leave myself a lot of room here. That's okay. Good enough. Okay, so let's fill in again, just whatever we can. We'll take it from there. So it looks like we've got all the resistances, right? We've got the, I'm just kind of reading in order, the 2.3 ohms. We've got the 3.9. Make that a little thicker. The 3.9, the 6.2. And the 20.1. 20.1 sounds like it's a voltage, and again, it's the battery, so we're going to plug that in as the total voltage. And so what we're looking for here is the potential difference, which again is just the voltage across the 2.3 ohm resistor. So we want the voltage used up by this resistor. We're looking for this box right here. And it's kind of a problem because we're missing a lot of information about that resistor, which is going to be a problem. So again, let's just find like something, like anything we can find that might be helpful. So I'm looking at, I don't know, looks like I have all the resistances, right? I've got the first one, the second one, the third one. I think I can find this total resistance. Even if you're not sure like why that would be helpful, let's just like find it. We'll see where that takes us. And for a series circuit, it's kind of like the third time around by now, we know that we can just add up those resistances. So that equivalent or total resistance is equal to the first one plus the second one plus the last one. And all of that gives you a value of, I forgot to work it out again. Alright, that gave me a value of, I got 12.4 for that one. 12.4 ohms. So I'm going to put that here. And again, we're still pretty far from where we need to be. We need to be up here. We need to be figuring out that voltage for that one resistor. So again, let's just like find something that we can find. And I'm looking at this row right here. So we know R and we know V. I think we can use that to solve for I. Using Ohm's law. R equals V over I. We're using that an awful lot for this topic. Alright, R equals V over I again. We're going to stay in this row right here. So I've got the 12.4 ohms is equal to, sorry about that, ohms is equal to, I think V is 20.1 for that row, and then we're solving for I. Some quick cross multiplication here. I got I is equal to, I got about 1.62. 1.62 amps, the unit for that. So I'm going to fill that in here, 1.62. Again, we're still pretty far from where we need to be, so we got to kind of keep going here. Well, one thing that I do know, the reason that that current might be helpful is in series circuits, we really like knowing what the current value is, because in a series circuit, the current is the same through all of the devices. So what I can do is I can just kind of fill that in for this whole row. 1.62 for that one, 1.62 for that one, 1.62 for the first device, and now we're kind of finally there, right? We can now solve for the voltage because we know the current, we know the resistance. All right, let's go. So R equals V over I. Alright, we know, again, we know that the resistance is 2.3. We're solving for the voltage, but we do know that the current is 1.62. Multiply across, and you get a velocity of, I got 3.73. 3.73. And that's our answer here. 3.7. Whoops, 3 volts. So for that one, kind of the trickiest one, and it's sort of a nice illustration of why we should use the verb chart, because it sort of helps keep you keep everything organized, and it helps you kind of figure out like what can you find next. Like, in other words, we knew all the resistances, and so we were able to find the total resistance. From there, we were able to find the total current. And then from there, we were able to fill in all of the currents. And then from there, we were able to find the voltage that we were looking for. So if you're ever stuck on one of these circuit problems, try setting up the verb chart. And just take it from there, one thing at a time. And sometimes it'll take more than one step, but eventually you should be able to get there.